This production by the VRDCA is not designed to assist in the actual forming of a roadway, but rather to highlight some of the long-term problems associated with the drainage, with floodways, with roadways across slopes. And by long-term I mean the 15 to 30-year period associated with the shaped road. It is becoming increasingly common now for pastoral properties to install formed roads into trucking yards, all accessed along shaped or crested roads. Most of these roads are installed and maintained by inexperienced operators to provide an all-weather access to service trucking times or shipping times or time-determined appointments.
This video will look at V-drains, floodways, formed roads across slopes and gully crossings, and aims to introduce their traditional methods of construction, the consequences that have arisen where installed incorrectly, and recommendations on how to best rectify these situations that are becoming all too common on formed roads right across the Australian rangelands.
Most people probably think that a formed road, or in this case, shaped or crested road, is round on top, but a grader 14-foot, 12-foot blade, they're straight edge, so a grader can't make it round. And what happens in a full maintenance grade, which formed roads should have, you get a running grade at the start of the season and just bring stuff up to lay back over the crest to compensate for any soil loss over the wet season. But a full maintenance grade should be done before the wet season in our case. But when the grader starts, he starts off, in this case we've got the batters coming down into the drain. There'll be one cut from the centre of that drain, or the edge of the drain. There's one pass up towards the crown of the road, and then in this case it's 6 cuts wide, so there's another cut up into there, another cut up into the centre of the road or the crown of the road, so that's 3 passes up. You pick the excess or try to sort the stones and sticks, rocks out, and then you've got 3 passes back down again, back down into the centre of the drain, and then that's across the floor or across the table drain, up the batter and out. So what actually happens is the formed road is more like a tent. 6 passes up across the crown of the road, 1 out, then 6 right back over, and then 1 out again that way then. Once you've done your maintenance grade on your road, that's when you usually come along and do all your drains. This is a fairly typical pastoral property V-drain designed to take water away from a formed road. This drain has not been maintained in the last few years, or hasn't been maintained well, in the fact that the operator in this case has left a windrow restricting the flows from the roadway into the drain, but the outlet of the drain has been silted up. What possibly may happen here in a big rainfall event is that the water could get in this drain, pool up, not be able to get away, and then could flow on down the direction of the roadway and create further problems back towards the creek crossing down the bottom of the slope. This old V-drain here has been rendered completely obsolete because the insufficient training bank or a lack of maintenance, the water flows coming down, some of the water steering coming through here but turning, going back into the roadway. Majority of the water is not even getting into the old drain, it's just going straight past. Somewhere in the next rainfall, all this training bank here will be completely swept away, rendering the drain completely useless.
Through installing a drain down the slope often means that there's very little soil left at the top to act as a training bank to steer the water off the road and down the drain. This bank eventually gets washed away, allowing the water to mostly bypass the drain, further eroding the road's edge as it flows on down the roadway. The excess soil taken down the drain then gets dumped at its far end, blocking the drain, causing the water to pond and the drain to silt up.
One of the disadvantages with the traditional methods of maintaining drains is when they start from the top, is removing soil from the edge of the roadway. There's less soil available to use as a training bank, and by training bank I mean that small wall of soil that ties the drain into the formed road to help steer the water out and away from the roadway. This drain is quite a few years old, but it's quite traditional that The maintenance has all come down the drain, the water flows have come down the drain, and in behind me now could be 30 to 45 centimetres of silt that's been deposited here over the years, and I can keep digging here for quite a while before I get to the end of this silt. And not only that, the grader has worked down the drain, and we can see here the last time this drain was maintained, this is where the grader stopped and left this great wall of soil here, reducing the effectiveness of the drain. Had the traditional methods been employed correctly here in the first place, this operator shouldn't have stopped here. He should have went through to the end of the drain and then tried to flare the drain out and open it up to remove the vegetation, to reduce, spread out the silt, to enable the water flows to continue on. My recommendation now is that we now start working the soil back up. We back down this drain with the grader, we collect the soil that has been pushed down here through years of incorrect maintenance and of water flows. We now start working this soil back up to compensate for the soil that's lost on the upslope side, on the inlet side of the drain, and also to provide more soil that is needed up here for the training bank, that wall of soil that ties back into the formed or the crested road to steer the water out and away.
By installing the drain up the slope, ensures that the end of the drain is kept open and that there is enough soil taken out of the drain to install a more defined training bank to steer the water flow off the road, down the drain, reinstating the water's natural flow.
It's quite easy to reverse a grader down here and work in complete opposite to the traditional methods and start trying to bring soil back up. Little demo here with the Tonka toy. It's just to sort of show the traditional ways or the standard methods that people maintain these drains, in this case this little V drain. Once he's done his road maintenance work, he'll pull off the road into a drain, pull off the formed road into the drain, drop the toe of his blade in the centre of the drain and proceed to cut down the centre of the drain with the windrow coming back up the side of the drain. So you go right through to the end of the drain and then stop. Reverses all the way back up to the start of the drain, swings his blade around and holds the hole cut again, cuts from the centre of the drain out, all the way back down to the end of the drain again. So it's two distinct passes, two distinct blade changes, the whole lot. He's taking everything down. But the drain will actually finish up like a big V shape, like a big funnel. Everything's wide at the mouth. As he gets down towards the end, it starts to close in. So in this case, he's got this big funnel shaped. Because he's grading down, he's taking all his soils down and any spare soil he has left all finishes up down the end. If that drain works, the water flows go down it, that water flow is all taking soil down. So after a few years, in this case 20, 25 years, whatever, there's a fair bit of soil that's down the end of that drain, and because the drain hasn't been cleaned out down the end, there's vegetation, weeds, trees, grass, whatever, and it's effectively acting like a plug at the end of the drain. We've got a drain that's either blocked up with poor maintenance or badly eroded. What they're starting to do now is open the ends up, and as the grader gets down to the end of the drain, they're starting to turn off and flare the ends out, open the ends out, just to remove the plug at the end of the drain. Most people accept the fact that they're not as effective or as good as they should be. A number of reasons there, which we'll come on to later. But one of the things now we're trying to turn V drains back into flat bottom drains. And this can be achieved quite simply. But as the grader comes into the drain, he's cutting from the high side back in towards the centre. So in this case, his blades on that same angle there, blades here, he's cutting from the high side in. He's sweeping this side of the drain into the bottom of the V, gets to the bottom of the drain, might turn off sharply, flare that out a little bit, back all the way up again, and his blade's already set on that angle. All he does is come back down the drain again, this time cutting from the centre back up and out. So he goes back down the drain again, follows his tracks down, hits the same flare, turns sharply out and gets to the end of the drain. This, after a few years, will gradually convert that V drain, this particular V drain, into a flat bottom drain.
Through converting V drains into flat bottom drains helps to take the force out of the water through presenting it with a larger surface area to spread out on. This means that drains can be shorter or even angled round to offer a larger exit point over which the water can trickle, reinstating its natural flow. Through grading up each side of the drain, soil is dug out from the outer edge of the V and transferred into its centre, gradually forming a flat floor within the drain.
After a few years, that V drain is gradually turned into a flat bottom drain. But with the benefit of hindsight, my recommendation is that we start working our soils back up the slope. Nature's taking the soil down, and we have the ability, machinery have the ability to work soils back up. In this case, as we come back up, as our grader comes back up the flat-bottomed drain, he comes up the road and he's bringing soils up that on his second pass. As he comes up, he's using those soils to tie the training bank back into the shoulder of the road, assist the water flows to find the outlet. This is an example of what was previously a traditional V drain that would have had a lot of silt down the bottom, maybe still working, but a lot of silt down the bottom, that type of stuff. We've actually turned that around. We've used that silt, brought that soils back up slope, back up the catchment, and we've tried to incorporate those soils into this training bank. This is what I call this wall of soil around here is the training bank. That's the outlet. But what was traditionally a V drain, after 15 to 30 minutes of work, we've turned that into a wide, flat bottom, shallow drain, which in the long term is more effective in taking the energy or the force out of the water flows, but it's also easier to maintain for a grader driver. He doesn't have to put in the amount of time with his gear changes. He can just go down one pass down, back up, flick that bit of a windrow back over on top of that again. But the wide flat bottomed drain is assisting to take the energy and the force out of the water flows. This particular watercourse starts right back up, possibly 2 kilometres away. It drains a fair area of high red ridge country coming down in there, so in a given rainfall event we can have quite a lot of water, millions of litres of water coming down through here, which in the past flew on with no defined drainage or creek line. We have to be extremely cautious when forming a road across a watercourse, and that quite often we can just be merely installing a mini dam bank that can hold water, trap the water on both sides of the formed road, which thereby allows the water to soak in. In some cases we actually make the watercourse more boggy than what it was originally.
An essential factor when installing culverts is to ensure that they're large enough to handle the volume of water flowing down the roadway as runoff, as well as that which will be coming down the hillside following the water's natural flow. Another method would be to extend a level floor using quality materials out from either side of the roadway to create a solid floodway, allowing the hillside and roadway runoffs to cross over the road following the water's natural flow.
In this particular instance here, the water is going to pool up. It won't get through these pipes fast enough, so the majority of water is going to flow on down the roadway and cross over the road back 50 metres behind us. So the cycle is going to start again. In a highway situation, this might be the case where they'll actually, the centre of the floodway itself will be concrete or bitumen, but whatever they do, they try not to interrupt or to slow down the water in any form. My recommendation be in a situation like this is that we may form the approaches of the watercourse, but the centre of the drainage line itself, my recommendation would be to, where possible, try to avoid the pipes, but if we had access to tip truck, is to box the roadway out, as in dig out those natural soils, which might be black soils or light sandy soils, box those out, put the gravel back in and reinstate the natural ground levels so that the water can flow across unimpeded. This is a fairly standard formed road across a slope. In this particular case, the country running up to my right and away down towards the drainage line to the left. My concern here is that after the soil loss from here in the last 25 years, the age of this roadway, the depth of the roadway below ground level. On the age of this road, at this case here now, it could be 1.5 metres below ground level. How deep will this soil loss be? How deep will this road go before this road is no longer trafficable. What's happening in this particular instance is the runoff off this big batter is 4 or 5 metres. The runoff from the roadway itself, which sheds almost as much water as a corrugated iron roof, the runoff from both those points is trapped here in this drain, runs from this particular instance another 300 or 400 metres down to where it can finally get over the road and away. But in this case now, this soil loss, all this stuff here is in transit, getting moved down deeper and deeper each year. So I would forecast that in another 25 years' time, this road will be another 3 or 4 metres deeper and beyond redemption, beyond economical repair.
The constant runoff coming down the road, plus the water running naturally down the slope, have ensured a gradual eroding of the drains, creating a narrowing of the usable road surface. To attempt to rectify the situation, the bank up from the high side of the road, called the batter, is the perfect stockpile from which to fill in the drains. Once they have been filled, the road surface will be widened across to the batter. This point should now be at the highest elevation on the road, allowing the use of the road's camber as a natural runoff across its surface. To further assist this movement, the installation of surveyed erosion banks trap the runoff, reinstating the water's natural flow.
Historically, this road might have been able to 2 road trains pass. Now we're getting that stage where 2 land cruisers are flat out passing. This particular concern here, or this particular issue, is nothing to do with formed roads, but just one that's quite relevant throughout Australia. In the past, if somebody came to a gully or a creek crossing, the standard procedure with grader or dozer would be to push that bank in, push the wall in, push that into the floor of the gully. Once they had access, get up the other side, push that back in, tidy it all up, and then carry on. And then following the rainfall and wet season, quite often if you had a 3 or 4 metre gully to get across, you'd have a metre of soil in the bottom. When that soil got washed away, was actually taken downstream, washed out on its way to sea, you would quite often finish up with a sharp drop-off before the floor of the gully and restricted access. This particular little washout here, for the want of a title, you see I've been in with a grader, just opened up for access for the station vehicles and quad bikes. But the main concept I'm trying to introduce here is to bring that soil back out. Cut the sides of the gully right back down to the floor of the gully and work the soils out. You might have to push it in for a start to get access, but once you've got access, then you can start working the soil out.
The standard method of gully construction has been to simply push in the 2 sides of the gully to form a bowl-shaped crossing point. The main problem here, however, has been that this newly formed roadway has created a raised crossing point, impeding the wet season water flow along the gully floor, which in time will get washed away, leaving a drop-off point at the middle of the crossing. An improved method of gully construction is to dig the roadway right down to the gully floor. This is done by first pushing one side of the gully in, then to continue pushing the soil across the floor before continuing up the far bank. Then to turn around and repeat this process in the opposite direction. Keep doing this until you have a bowl-shaped crossing point that slopes down to and across the level gully floor before sloping back up and out on the far side. Any excess soil is best used in the formation of banks on either side to prevent excess runoff from the road, hastening further erosion.
So that any water flows now are not going to be steered into the cutting. In this case, there's no particular road going off. It was just a cutting to provide access. But I've tried to minimise the soil, brought it back out, stockpile the soil in a bit of an untidy diversion bank. The examples of drainage in this production are standard throughout Australia. And with the benefit of hindsight, we know now that those old methods contribute to excessive soil loss, to expensive maintenance and time-consuming redesigning. In conclusion, I ask you to remember the 2 golden rules. 1, reinstate the natural flow direction as often as possible. And 2, the washout is the result and not the problem.